Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0812, refers to the transmission range switch ATP R switch issue within the 2012 to 2017 Honda Accord. This error indicates there's an issue with the electrical circuit tied to the transmission range switch, which is a crucial component responsible for conveying the gear selection of the transmission to the powertrain control module, PCM. If this switch malfunctions, it can impede proper gear shifting and affect driving performance. It's important to note that this code does not relate to mechanical issues within the transmission itself. Therefore, any troubleshooting steps should focus solely on the electronic side, including checking connections, wiring, and the switch itself. Before beginning repairs, ensure to gather all relevant freeze data and on-board snapshots using the HDS, Honda Diagnostic System, for accurate diagnostic insights. In conclusion, the DTC P0812 highlights a concern primarily rooted in electrical issues concerning the transmission range switch rather than mechanical transmission problems. Effective troubleshooting requires a systematic approach, focusing on verifying the switch, checking wiring integrity, and ensuring all connections are secure. The importance of engaging the HDS tool throughout the troubleshooting process cannot be overstated, as it provides invaluable insights into the condition of the ATR switch. By following the outlined steps meticulously, including final repair verification, you can ensure successful resolution of the fault. Taking preventive measures in maintaining connections and updating software can help in avoiding future occurrences of DTC P0812, ensuring reliable vehicle operation in the long run. The primary component implicated in DTC P0812 is the transmission range switch, also known as the ATP R switch. This switch plays a vital role in determining the position of the gear shifter, i.e., whether it is in park, reverse, neutral, or drive. It communicates this information directly to the PCM to ensure accurate gear shifting and effective vehicle operation. Location-wise, you can find the transmission range switch connected to the transmission assembly. It is typically encased within the 10P connector, located near the transmission housing. The switch has specific terminals that must maintain proper connections for the vehicle's electronic systems to function correctly. If there's an electrical failure or poor connectivity within this component, it can trigger DTC P0812. The causes for the DTC P0812 mainly stem from electrical circuit problems rather than mechanical faults within the transmission itself. One primary cause could be issues with the connectors associated with the transmission range switch. Over time, connectors may become corroded or loose, preventing proper electrical flow. Another cause could be concerns with the wire integrity of the ATP R line, which connects the transmission range switch to the PCM. This wire must remain intact without breaks for the switch to operate effectively. Understanding these potential causes is crucial for effective troubleshooting, helping pinpoint where the failure might lie within the electrical circuit, allowing for focused and efficient repair efforts. When DTC P0812 is active, specific symptoms may manifest, indicating that the issue is impacting the vehicle's operation. One of the common symptoms is gear shifting problems, which can include delays in shifting or the inability to change gears altogether. The vehicle may also engage the check engine light, alerting the driver to a malfunction within the transmission system. Moreover, limited vehicle functionality can occur. For instance, the vehicle may not start when in certain gear positions or may exhibit unusual behavior when in reverse. Recognizing these symptoms early can help in promptly diagnosing and rectifying the issue related to the transmission range switch. ensuring optimal transmission performance and safety on the road. The first troubleshooting step involves verifying the reported issue using the HDS, or Honda Diagnostic System, to check the ATR switch's condition. Begin by pressing the engine start/stop button to select the on mode, which powers the vehicle's electronic systems without starting the engine. Next, check the ATR switch's current conditions and values with the HDS while the shift lever is positioned in reverse. Confirm whether the current conditions match the specified threshold. If they do match, it might indicate an intermittent failure, suggesting that the system is functioning correctly at that moment. However, if the conditions do not align with the threshold values, proceed to the next troubleshooting step, as this discrepancy indicates an underlying issue that requires further exploration. The second step in troubleshooting involves isolating potential failure areas within the system, particularly focusing on the transmission range switch and the ATPR line. First, turn the engine off and disconnect the 10P connector associated with the transmission range switch to isolate the switch from the PCM for testing purposes. You will need to connect terminals A and B with a jumper wire for the next part of this test. Terminal A is located at number 8 on the transmission range switch's 10P connector with a white wire, while Terminal B connects to body ground. After establishing this connection, turn the engine on and reevaluate the ATR switch condition through the HDS once again. If the current conditions do match the specified threshold, it confirms that the transmission range switch is faulty and needs replacement. However, if they do not match, further investigation into wiring continuity is necessary. The third troubleshooting step is to conduct an open wire check on the ATPR line to verify continuity between key test points. Start by selecting the off mode using the engine start-stop button, and jump the SCS line with the HDS tool to enter the short check mode. After that, disconnect the PCM connector A, 51P, to isolate it from the circuit. With the transmission range switch still disconnected, perform a continuity check between test points 1 and 2. Test point 1 is at number 16 on PCM connector A with a green wire, and test point 2 is to the body ground. An affirmative continuity reading indicates that the ATPR line is intact, leading to the next recommendation of updating the PCM software or substituting it with a known good unit. Conversely, if continuity is absent, an open circuit exists in the ATPR line between the transmission range switch and the PCM, necessitating repairs in that wire pathway. After successfully implementing repairs for the DTC P0812, the critical step is conducting a thorough final repair verification process. Begin by carefully reconnecting all connectors that were previously disconnected during troubleshooting to ensure each connection is secure. Using the HDS, clear the DTC from the system memory to reset the error state, which prepares the vehicle for new diagnostic checks. Subsequently, start the engine and initiate a test drive, making sure to shift into reverse at lower speeds of below 3 miles per hour for a duration of at least 2 seconds. Then increase speed and drive over 3 miles per hour for 2 seconds more. Following the test drive, monitor the OBD status using the HDS to check if DTC P0812 indicates passed, suggesting successful resolution. If it indicates failed or not completed, further checks for poor connections or loose terminals would be necessary. As part of preventive maintenance to avoid reoccurrence of DTC P0812, regular inspections of the connectors and wiring related to the transmission range switch can be vital. Ensure that all connectors are clean and tightly fitted to prevent corrosion or disconnection issues that can arise over time. Moreover, maintaining the integrity of electrical connections and verifying their functionality during routine vehicle checkups can significantly enhance system reliability. Additionally, always ensure the PCM software is kept up to date with the latest version. Outdated software can lead to communication failures and erroneous DTC readings. Routine maintenance practices like these will help in ensuring a well-functioning transmission system, ultimately promoting reliable vehicle performance and safety. Please like and subscribe to the channel. See you next time!